Gravitational waves are invisible ripples in the fabric of space-time, detected only by observing the absolute absence of vibration inside a 4-kilometer vacuum. Though anomalous cognition, the remote viewing team successfully penetrated the facility's layered defenses, bypassing the runway illusion, piercing the concrete arches, and entering the vacuum tube to accurately describe the splitting of light and the detection of cosmic frequencies. And Sandra just wrote this in her S6. I can't wait to see what this is, so I thought I'd throw that in there. LIGO Hanford Observatory, Benton County, Washington, photographic timeline. Two perpendicular 4-kilometer arms stretching across a flat desert inside a 1.2-meter steel vacuum tube designed to detect gravitational waves, distortions in space-time measured at a fraction of the width of a single proton. So target MRWD KTQF was the target at the LIGO Hanford Observatory in Eastern Washington on the ground as it stands. And this is a great like schematic of, or the same view of the overhead of the interferometer. And you can see that the laser light is sent into the instrument to measure changes in the length of the two arms. A beam splitter splits the light and sends out two identical beams along the 4-kilometer long arms. The light waves bounce off a mirror and return back to the center station, and a gravitational wave affects the interferometer's arms differently. When one extends, the other contracts as they are passed by the peaks and troughs of the gravitational waves. Normally, the light returns unchanged to the beam splitter from both arms, and the light waves cancel each other out. If the arms are disturbed by a gravitational wave, the light waves will have traveled different distances. Light then escapes through the splitter and hits the detector. So the LIGO was designed to open the field of gravitational wave astrophysics to the direct detection of gravitational waves predicted by Einstein's general theory of relativity. The multi-kilometer scale gravitational wave detectors use laser interferometry to measure the minute ripples in spacetime caused by passing gravitational waves from cataclysmic cosmic events such as colliding neutron stars or black holes caused by supernova. Okay, you guys ready? First up, we got Leah. So in her S2, she picked up on the acoustic profile. She's got humming, vibrating, ringing, metallic, buzzing, accurately captures the intense acoustic reality of the massive machine-heavy physics in the laboratory. Then later on, she picked up cold, frozen, crackling, snapping, condensed moisture, representing the extreme physical and cryogenic conditions required to maintain the high-tech vacuum equipment. Then later in her S4, in her structure 2, she picked up sort of like this stone brick structure, which was the outside of the arm. And in her ideograms, her page 1, she picked up on the initial structural impressions capturing massive vertical anomalies. And in her page 2 on her ideograms, she picked up the L-shaped mirrors in the macro geometry of the facility. And I put a little schematic. You can kind of see the gestalts there. The L-shaped and the vacuum beam tubes, an exact match for LIGO's 4-kilometer perpendicular vacuum beam tubes, capturing the unique foundational footprint of the facility. And she also picked up on the direct structural match to LIGO's end stations, the terminal buildings housing the massive circular suspended test masses mirrors at the exact end of each vacuum arm. Okay, moving on to Josipa. In her S2 Playfair, she picked up on the environment, and I put a heat map over her drawing so you could really see the details of the landscape of the Eastern Washington desert. And she's got the dried land, landfill, cold, warm, dried and cracked soil. Really picks up on the environment. And then also in her Playfair, she picked up on this S-shaped waving zigzag motions like a snake in a grass. And she also put loud, repetitive pattern movement, a square made of left, right, zigzag, a circle made of swirls from outside in, repeating. And it really picked up on those gravitational waves that they're measuring. So this one was really cool. This was in one of her ideograms, and Josipa's drawing was the chair that I put in hot pink on this horizon line. And so I overlaid a a schematic of the base over the chair. And from the video we saw, you can see that the chair, I kind of saw the chair as like the observer station where you're looking down on that horizon, down the beam of the tube. And I just thought that was so cool how she kind of captured the metaphor of the whole project, looking down the horizon line to the mirrors and what's going to be recorded. So I thought that was really cool. Sandra honed in on the energy manipulation at the center of the facility, sketching a glowing, radiating diamond shape, a near perfect conceptual metaphor for the laser beam splitter. And Dean Cabrera corroborated this by noting distinct shafts of light. And then Sandra also picked up on these computer, keyboard, people, and you can see it's almost exactly like these guys in the control room um, below. You can see the monitors in the room, and really picked up on that gestalt. Computer, people, electrical, screen. Yeah, just the computer, electrical, and it just picks it up with the guys in the control room. I thought that was awesome. And then this one, I mean, if you notice the if you look at the colors that even Sandra added to this one, it almost is an identical match to one of the monitors up on the screen where they're measuring the frequency wave, the frequency waves. So I thought that was just a great capture. Really cool right there. And then here's another one where she had this group of people in a circle chanting, and then she had another one of this person kind of looking down the tube. And so I overlaid one of the scientists working on the in the tube, and it just totally it like really it really matched up cool. So I threw that in there. And then this one was really just incredible. You can see the laser beams being bent backwards, and almost it's like the perfect metaphor being bounced back down the vacuum tubes to be recorded. So just a great capture there of the whole process. And again here, she had this guy looking down, looking through the like this laser, almost looked like this portal that the guy was looking through. And I thought this really matched up with this one of the scientists working on the laser. And again, she had this image here of this refracting laser lights. And I kind of picked up that these were like the scientist observers. Despite viewing a static concrete structure, the team was overwhelmed by acoustic data. Victorita clearly documented distinct piano sounds and musical sounds, while Sandra heard rhythmic chanting and reciting. Viewers captured the human element of high-tech observation and data manipulation. Sandra noted a think tank type of scenario with screens describing people standing as a witness to something emerging from a cloud or ether. Okay, moving on to Dean. Dean accurately captured the macro environment. His sketches an unbroken horizontal line, noting the area as flat, desolate, and sun-scorched, just like the Eastern Washington. And I also highlighted also scientific study going on. So really cool hit right there. And then I overlaid that schematic of LIGO, and in his ideogram, you can see it really matches the whole gestalt of the base. And then he also got it again here with one of his second ideograms. And I just put another schematic of the or another image of the laser beam, the L beam here, and it just really lines up. So he hit it right off the bat. And then this shot was real. I thought this shot was really great. It was more of like a bird's eye view looking down of the base, and you could see the L shape. It was more like an X shape, and they were kind of on pillars, like the station has the arms going out, the 4 kilometer arms going out. It really picks up the gestalt of the whole base. So I just overlaid that over it. And then Dean started to talk about these clusters of tubes that were grouped together, large clusters in these formations, and these vertical group tubes. And so I just overlaid kind of the base tubes of next to each other. He really picked up the gestalt of the base. And then again here he had areas of focus and observation within a larger area, sharp verticals everywhere, but focused also in certain areas, metal painted, people observing, um, unra screens bent vertical shafts of light, which totally picks up on it. And he's got these gray tubes, which just accurately describe the base. And so this one was really cool. This was Dean's S3. But what I did here, what kind of stood out to me was these beams that were shooting in. So I flipped it horizontally and sort of pulled it apart and added the laser image to give you the idea of kind of what I was seeing when I was looking at his S3. And you can see if you put the laser light and the mirror on each side, it really picks up the whole, not only like the metaphor of the tubes, but the whole, like, the an actual picture of the experiment going on. Thought that was just great. All right, Jeremy. And right off in one of his S2, he mentioned the landscape was vast. So I overlaid this picture. It's a great hit. Yeah, and Jeremy really picked up on the same sort of concrete brick structures. Um, and this he had this another tube picture in one of his S2s. So I just overlaid that of the guys working inside the tube. It matched up perfectly. And then here he had just like all kinds of gestalts that just were hitting the base itself. Like he had these swirling tubes, like the lasers going down the arms. The concrete structure. And you could think of this one down here as either like a spinning atom ball, which they're measuring. I put right here, or you could think you're just looking down the tube. And I also thought that these were kind of, it's just very similar to the arms in the observatory. So I thought that was a great hit, Jeremy. Yeah, and LIGO's most defining visual feature are its two 4 kilometer long, perfectly straight arms. To the human mind, massive straight lines on a flat terrain immediately suggest one thing: an airport runway. So when I was looking at all these, like a lot of his S4, it totally looks like, and then when you lay this picture, for this bird's eye view of the base, it totally looks like an airport. So I had to throw that on there. Both him and Racine got a lot of airport, um, like planes. And I was thinking, oh my gosh, if I was viewing this, I would have totally picked up on that. And yeah, so moving on to Racine, yeah, one of his S4, he had this guy in what looked to me like a jumpsuit, a human sitting reading something, and I kind of picked up that this was the one of the scientists working on the laser, just sitting there like kind of working, reading on it. Then he had another, well, here in his S3, he had these round structures with these humans working in it. And so I kind of just overlaid this back. It picked up on it, which was a great one. Viewers sense extreme emptiness and elements hovering without gravity. Racine uniquely captured the functional essence of the pendulum suspension system, and he mentioned human floating in a narrow tube, and the things floating is important. Okay, so this one was really great. He had this guy inside of the tube, so I just overlaid the picture, and you can see all the scientists working on the laser inside the vacuum tube, and he even put human inside narrow tube. Racine bypasses the concrete exterior entirely. His data accurately isolates the core cylindrical architecture, explicitly noting and sketching a narrow tube structure. So great job, Racine. Really cool. All right, Chris. He sent in his S2, he had this cone shape with a lot of energy underneath it. And I thought that matched up to this one of the scientists working on this I guess this is part of the laser, and just kind of matched up there. And then he also really picked up on the whole gestalt of the base, so I just overlaid another schematic of, there's the laser, and he had these real bright laser shining gestalts like in his S2 here that really just matched up. So it was a really cool hit there. All right, Victorita, right away in her one of her first ideograms, she just picked up on this figure, which I really thought was like one of the scientists looking down the laser tube, and it really matched up with this picture right here. I thought that was cool. And so in her S4, she picked up on this beam of light, and she had these something familiar to a sickle. And so I just wanted to play something for you guys real quick. This is going to blow you guys away. So yeah, that's definitely the sickle that she was picking up. So I thought that was a great hit there. Yeah, then she got these long structures, like with a high obstacle and an entrance with a beam of light. Just really picked up on the going into the center station and the arms extending out. And then again here, I just overlaid one of the arms that kind of just gives you sort of the gestalt of the whole base. And she mentioned a dark background, like a dark blue wall, and she had this curved sort of entrance right there. So I just overlaid that picture there. It came out, it really matched up. Yeah, and the viewers repeatedly sketched massive arched concrete structures, tunnels, and repetitive structural blocks. Victorita explicitly labels her arched sketch as a large, wide concrete structure. And so she really just got some great hits of the base here. Yeah, so then we had some corroboration between some of the viewers. Jeremy and Racine picked up on sort of the runway airplane gestalt of the whole base, and Victorita and Jeremy picked up on the arched concrete structural blocks. Sandra and Dean picked up on those bright laser radiating diamond shafts of light. And then, like we saw at the end there, Victorita and Sandra picked up on these acoustic chirps, like piano sounds and rhythmic chanting from those chirps that we just heard. So great job, guys! Really, really, really nailed this one. And And of course, great job for Brian for targeteering this. And thanks, you guys.